Welcome back, my friend. It's so wonderful to have you here tonight, settling in for another journey through the cosmos together. Tonight, I've got something truly special for you, something that's going to completely change how you think about sunlight. You know that warm feeling when sunshine touches your face? Well, here's something incredible. That light you're feeling, it's ancient, impossibly ancient, because every single photon of light that warms your skin has been on a journey that took over 100,000 years just to reach you. Can you imagine that? 100,000 years, traveling through the heart of our star, just to dance across your face for a fraction of a second. And you know, if you're finding some peace in these cosmic stories, if they're helping you drift off into beautiful dreams, I'd be so grateful if you gently tap that like button. It really helps other restless souls find these peaceful journeys too. And if you haven't subscribed yet, well, there's a whole universe of sleep stories waiting for you. Just a gentle tap and you'll never miss another voyage through the stars. Maybe leave a comment tomorrow about which cosmic mysteries help you sleep best. But for now, there's no pressure at all. We're just here together, floating through space and time. So let's get comfortable now. Really comfortable. Let yourself sink into wherever you're resting, feeling the weight of your body becoming heavy, like you're made of stardust that's finally found its home. Take a breath with me. A deep, slow breath, breathing in the darkness of space and breathing out any thoughts from your day. That's it. Just like that. And as you breathe, imagine you can feel time itself slowing down around you. Because tonight, we're going to experience time the way a photon does, where 100,000 years can feel like a single heartbeat, and a single moment can stretch into eternity. Your breathing is already matching the rhythm of the universe, slow and steady, ancient and peaceful. Tonight's journey is different from anything we've done before, because instead of starting at the beginning, we're going to start at the end. You see, right now, scattered throughout the observable universe, there are photons that left the sun when you were just a child. They're out there in the cosmic dark, having traveled for years through space, and they remember everything. They remember you. They remember Earth. They remember their long, long meditation inside the sun. And that's what makes tonight's story so special. We're going to follow one of these ancient photons. We're going to be that photon. And we're going to remember our journey backward through time. You're going to discover what it feels like to drift through intergalactic space, where there's nothing but darkness and peace for millions of miles. You'll remember passing through Earth's atmosphere, that gentle, playful dance through air molecules, creating the blue sky that humans love so much. But most beautifully, most hypnotically, you'll remember those 100,000 years inside the sun. That incredible, patient journey from the core to the surface, bouncing gently from atom to atom. Each collision like a soft greeting, a gentle hello between old friends. The scientists call it a random walk, but there's nothing random about it when you're experiencing it. It's more like a meditation, a cosmic dance that takes 100 millennia to complete, where time doesn't mean what it means to humans, where patience isn't even a concept, because you're pure energy, pure light. just peacefully finding your way through a stellar maze. And here's what's so beautiful about this backward journey. As we travel deeper into your memories as a photon, as we go further back in time, everything becomes simpler, quieter, more peaceful, until we reach that perfect moment of your birth, that instant of pure creation in the heart of a star, when you first came into being. But we'll take our time getting there. We've got all night. And after all, you've already waited 100,000 years. What's a few more hours between friends? So let yourself drift now. Let your mind become light itself, weightless and timeless. As we begin at the very edge of everything, at the boundary of the observable universe, where you've been traveling for so very long, and where your ancient memories begin. You're here now, at the very edge of everything that can be seen. 13 billion light years from home, and you're still traveling, still moving at that perfect, constant speed that defines what you are. You're pure light, ancient light. And from here, looking back, you can see the entire story of the universe spread out behind you, like a vast, glowing tapestry. Every galaxy you've passed is a memory now, frozen in your electromagnetic essence. You remember them all. The spiral ones that spin like cosmic pinwheels, the elliptical ones that glow like golden eggs floating in the dark, the irregular ones that dance to their own mysterious rhythms. They're all behind you now, getting smaller and dimmer with each passing moment. But you remember when they were close, when their gravity gently bent your path, not enough to capture you, just enough to say hello. It's so quiet out here, so perfectly, absolutely quiet. There's no sound in space, of course. There never has been. But the silence here at the edge of everything is different. It's deeper, older, more complete. You're in the space between spaces now, where even the cosmic microwave background radiation whispers more softly, where the universe itself is stretching, expanding, carrying you along like a leaf on an infinite ocean. You've been traveling for so long, but time doesn't tire you. It can't. You're timeless in the truest sense. You move through time, but you don't experience it the way matter does. To you, this journey from the sun to the edge of the observable universe, these billions of years, they're just now, always now, an eternal present moment that stretches and stretches but never breaks. And yet, you remember. Oh, how you remember. Every single moment of your journey lives within your wavelength, encoded in your frequency, written in the language of light itself. You remember Earth, that beautiful blue marble that you left so long ago. You remember the sun, your home, your birthplace, that magnificent star that held you close for so very, very long before finally letting you go. The darkness here isn't frightening. It's peaceful, profoundly peaceful. It's the darkness that exists between galaxies, between thoughts, between heartbeats. You float through it effortlessly, naturally, because this is what you were made to do, to carry information across impossible distances, to be a messenger between stars, a whisper of energy that connects everything to everything else. Sometimes you encounter other photons out here, ancient light like yourself. Some left their stars when the universe was young. Others are fresh from stellar nurseries that won't be discovered by Earth's telescopes for millions of years. You pass through each other without stopping, without slowing. But somehow you know each other's stories. You're all part of the same cosmic conversation, all carrying messages that someone, somewhere, somewhen might receive. The universe is so much emptier here than humans imagine. The space between galaxies isn't just vast, it's incomprehensibly vast. If the universe were shrunk down so that Earth was the size of a grain of sand, the nearest galaxy would still be several miles away, and you've crossed those miles, those billions and billions of actual miles, one wavelength at a time, never rushing, never slowing, always moving at exactly the speed of light, because you are light. Looking back through your memories, you can see the path you've taken, not as a line through space, but as a kind of golden thread woven through the fabric of space-time itself. It winds and curves where massive objects bent space around them. It sparkles where you passed through cosmic dust clouds. It glows where you streamed past stars. And now you remember. You're approaching that special part of your journey, when you were traveling through the vast spaces between galaxies, through what humans call the cosmic voids. These voids are the largest structures in the universe, or rather, they're the absence of structure. Enormous bubbles of nearly nothing, hundreds of millions of light years across, where galaxies are rare and dark matter is sparse, where you could travel for eons and encounter almost nothing at all. And you did. You traveled through them, through that profound emptiness that makes up most of the universe. But empty doesn't mean boring, not when you're light. Every moment in those voids was a meditation, a chance to simply be, to exist in your purest form without interaction, without interruption, just you and the expanding universe, dancing together in perfect harmony, your wavelength stretching ever so slightly as space itself expanded, getting a tiny bit redder, a tiny bit longer, like a cosmic yawn that takes billions of years to complete. In the voids, you had time to remember everything, to replay your entire existence like a song that never gets old. You remembered your birth in the sun's core, that moment of pure creation when hydrogen became helium and you burst into being. You remembered your 100,000-year journey to the sun's surface, bouncing from atom to atom in a patient, peaceful dance. You remembered your 8-minute sprint to Earth, and that magical moment when you first touched the atmosphere. The voids are where photons go to dream, if light could dream, and maybe it can. Maybe that's what you were doing all those eons, dreaming of warmth and matter and interaction, dreaming of the time when you were surrounded by the dense plasma of the sun, when every nanosecond brought a new collision, a new direction, a new dance partner. It's so different from the sun, these voids. Inside the sun, you were never alone. Never. You were constantly embracing atoms, bouncing off electrons, playing an endless game of cosmic pinball where every bounce was gentle, friendly, warm. But in the voids, you're the loneliest thing in the universe. And yet you're not lonely. You can't be lonely. You're complete in yourself. A perfect packet of energy that needs nothing, wants nothing, just is. Sometimes in the voids, you'd encounter a single hydrogen atom, floating there in the darkness, like a lost thought. The space is so empty that there might be only one atom in a volume the size of a basketball, and yet you'd find each other. you and that atom, drawn together by the fundamental forces that govern everything. You'd interact for the briefest moment, less than a trillionth of a second, and then continue on your separate ways. But that moment would be recorded in your wavelength forever, a tiny shift in your frequency that says, I met someone here. I wasn't alone. The cosmic voids taught you patience, if you could learn. They taught you that emptiness isn't empty. It's full of potential, full of space for things to happen, full of time for memories to settle like dust in sunlight. Except there's no dust here, and you are the sunlight, carrying your memories across distances that make the word distance lose all meaning. And through it all, through every empty light year, through every eon of solitude, you never slowed down, never sped up, never wavered from your purpose. You're a messenger, remember, carrying information from the heart of a star to wherever the universe will take you. And the message you carry is simple, beautiful, eternal. It says, once there was fusion. Once atoms danced. Once energy was born in the heart of a star. And I am the proof. I am the memory. I am the light. Now your memories grow warmer, closer, more familiar. You remember when the darkness began to fill with stars, not just the distant smudges of far-off galaxies, but real individual stars, millions of them, billions. You were entering your home galaxy, the Milky Way, that beautiful spiral of light that Earth's astronomers photograph on clear mountain nights. Except you were seeing it from the inside, living it, dancing through its spiral arms like a cosmic ballet that lasted millions of years. The Milky Way welcomed you back like an old friend. Its gravity, the combined pull of 400 billion stars, dark matter, black holes, all of it together, gently curved your path into a graceful arc. You weren't captured. You're moving too fast to ever be captured. But you felt its influence, the way a bird might feel the wind. Subtle, natural, perfect. You entered through the galaxy's halo first, that sphere of ancient stars and dark matter that surrounds the bright disk like a cosmic atmosphere. The stars here are old, so old, some of them nearly as ancient as the universe itself. Red giants that have swollen up like tired balloons. White dwarfs that shine with the last heat of their youth, and scattered between them globular clusters. Those perfect spheres of hundreds of thousands of stars all bound together, dancing around each other in a choreography that's been going on for 12 billion years. As you moved deeper into the galaxy, the stars grew younger, brighter, more energetic. You were approaching the disk now, that flat spiral where most of the galaxy's stars live, where new stars are still being born, where your own sun spins along with everything else. 230 million years to complete one galactic orbit. Though you've been traveling for so long that the sun has completed dozens of orbits since you left it. The spiral arms were the most beautiful part. These aren't solid structures. They're waves. Density waves that move through the galaxy like ripples on a cosmic pond. Where the waves compress the gas and dust, new stars are born. Bright blue giants that burn fierce and fast. And you pass through these stellar nurseries, through clouds of glowing hydrogen where baby stars were just beginning to shine, through regions where the radiation from massive stars had blown bubbles in space, cavities of hot, thin gas surrounded. by shells of cooler, denser material. You remember the colors. Oh, the colors. The galaxy isn't just white points of light against black. It's a painter's palette of cosmic hues. The pink glow of hydrogen nebulae, the blue-white fire of young star clusters, the golden warmth of older stars like your sun, the deep red of carbon stars, the ethereal green of oxygen in planetary nebulae. Every color tells a story. Every wavelength carries information about temperature, composition, motion, age. Between the spiral arms, you traveled through quieter regions, areas where stars are more spread out, where the space between them can be several light years. These inter-arm regions are like the galaxy's suburban neighborhoods, peaceful, stable, where stars like your sun can orbit quietly for billions of years, raising families of planets, maybe even nurturing life. Sometimes you passed close to other stars, not collision close. Nothing in the galaxy really collides, but close enough to see their planets, to watch their stellar winds streaming out into space, to observe the dance of binary stars spiraling around each other. Some of these stars were monsters, blue supergiants 1,000 times brighter than your sun, so hot they were literally evaporating, losing mass in stellar winds that could strip the atmosphere from a planet. Other stars were so dim you almost missed them. Red dwarfs, the universe's most common stars, burning their hydrogen so slowly they'll still be shining when the universe is 1 trillion years old, long after stars like your sun have faded to black. You passed brown dwarfs, too, failed stars that never got quite massive enough to sustain fusion, glowing with the dim heat of their slow gravitational collapse. And through it all, through every light year of your galactic journey, you were never truly alone. The galaxy is full of light, photons like yourself, each on their own journey. Some racing outward like you, others moving inward, others orbiting in endless loops around the galactic center. You're all part of the same grand symphony, billions upon billions of notes of light, creating a song that's been playing for 13 billion years. You remember passing through a nebula once, a stellar nursery where new stars were being born. The gas was so thick compared to empty space, millions of atoms per cubic inch instead of just one. And your journey slowed, not your speed. You always move at the speed of light. But your path became a maze, bouncing from atom to atom, absorbed and re-emitted, scattered and re-scattered. It reminded you of something ancient, something from long, long ago. Oh yes, it reminded you of your time inside the sun, that 100,000-year meditation. But this was briefer, just a few thousand years to cross the nebula, a heartbeat compared to your solar journey. The galaxy taught you about scale, about how something can be impossibly vast and still be just a tiny part of something even vaster. The Milky Way, your home galaxy, 100,000 light years across, containing hundreds of billions of stars, and yet it's just one galaxy among trillions. Your sun, that mighty star that held you for so long, is just one ordinary star among those hundreds of billions. Earth, that precious blue world you remember so fondly, is just a mote of dust orbiting that ordinary star. And yet, each piece is precious, each star unique, each photon carrying its own story. You're not insignificant just because you're small. You're part of the whole, a thread in the cosmic tapestry. Without you and billions of photons like you, the universe would be dark. And darkness isn't just the absence of light. It's the absence of information, of energy, of the connections that make the universe a universe instead of just empty space. Now your memories are pulling you deeper, closer to home. You remember approaching a familiar region of the galaxy, a quiet area about 26,000 light-years from the galactic center, in a spur off one of the major spiral arms. It's getting so familiar now, you can almost feel it, that gentle pull. Not gravity exactly, but something else. The pull of memory, of origin, of home. You're remembering now when you first realized you were approaching your birthplace, your solar system. It didn't announce itself with fanfare. There was no clear boundary, no welcome sign, just a gradual realization that the stars were thinning out in a familiar way, that the cosmic dust had a particular quality you recognized, that you were entering the sun's extended sphere of influence. The first hint was the heliopause, that bubble where the solar wind meets the interstellar medium, where the sun's magnetic field finally gives way to the galaxies. You passed through it like passing through the gentlest whisper, barely noticeable, but you noticed, because this was your sun's breath reaching out into space. These were particles that had escaped the same star that gave you birth. They were like distant cousins, products of the same stellar furnace. Then came the Oort cloud, that vast sphere of icy bodies that extends nearly a light year from the sun. Trillions of comets sleep here in the cold, waiting for gravity to nudge them toward the inner solar system. Some of them have been here since the solar system formed, 4.5 billion years ago. They're time capsules, frozen messengers from the epoch when planets were still coming together from dust and gas. You passed some of these sleeping comets, dark chunks of ice and rock no bigger than mountains, invisible in the darkness. But you could sense them by the way they ever so slightly warmed when your ancient starlight touched them. For just a moment, less than a moment, you raised their temperature by a fraction of a degree, the first warmth they'd felt in millions of years. Moving inward through your memories, you encountered the Kuiper Belt, that disk of icy bodies where Pluto lives along with thousands of other dwarf planets and smaller objects. It's like a frozen museum of the early solar system, preserving the building blocks that never quite became planets. You remember how some of these objects have their own tiny moons, little binary systems dancing together in the cold, held together by the gentlest of gravitational embraces. Neptune appeared in your memory like a blue jewel in the darkness, that gorgeous ice giant with its deep azure atmosphere and its wild winds, the fastest in the solar system. You didn't pass too close, but close enough to see its storms, to watch its large moon Triton orbiting backwards, a captured Kuiper Belt object that Neptune adopted as its own. The planet's magnetic field tugged at you slightly, trying to spiral you into its radiation belts. But you were moving too fast, too free. Nothing could capture light. Uranus came before Neptune in your backward journey through memory, that strange, tilted world that rolls along its orbit like a cosmic bowling ball, spinning on its side for reasons that astronomers still debate. Maybe a massive collision long ago. Maybe gravitational interactions with Jupiter and Saturn. But you don't need to know why. You just remember its pale green glow, its thin rings that are almost invisible, its family of moons dancing around its tilted equator in perfectly circular orbits. Saturn. Oh, Saturn. Now there's a memory that shimmers and glows. You remember approaching this magnificent giant with its impossible rings. Those billions of ice particles all orbiting in perfect synchronization, creating a disk so thin that when it's edge on to Earth, it disappears completely. You pass through the outer rings, through gaps maintained by tiny shepherd moons, through regions where the ice particles are as fine as smoke, through other regions where they're as big as houses. The rings sang to you, not with sound, of course, but with light. Each particle reflecting sunlight, your cousins, other photons that had made the same journey you're remembering now. The whole system sparkled like a cosmic disco ball, but peaceful, hypnotic, mesmerizing. You could have spent eons just watching the patterns, the spokes that appear and disappear, the waves that ripple through the rings when moons pass by, the braided rings that seem to defy physics until you realize it's just gravity and orbital mechanics creating art. Jupiter loomed in your memories like a giant eye watching over the solar system, that enormous ball of gas that could swallow 1,000 Earths. Its great red spot, that storm that's been raging for at least 300 years, maybe much longer, looked like a whirlpool of clouds painted in shades of salmon and rust. You remember its radiation belts, so intense they could fry a spacecraft's electronics in minutes. But to you, they were just another form of light. Electromagnetic cousins saying hello. The asteroid belt wasn't the dense field of rocks that movies show. It was mostly empty space with occasional worldlets floating in the darkness. Ceres, the largest, a dwarf planet in its own right. Vesta, with that giant crater that nearly shattered it. Countless smaller bodies, some metallic, some rocky, some a mixture of both. The leftover building blocks of a planet that never formed, kept from coming together by Jupiter's massive gravity. Mars appeared as a rusty pearl, that red planet that humans dream about visiting. You remember its polar ice caps, its massive volcano Olympus Mons that rises 13 miles above the surface. Its canyon system that would stretch across the entire United States. But what you remember most is how thin its atmosphere is. Barely there. Just enough to create dust storms that can engulf the entire planet. Just enough to scatter light and create those butterscotch skies that robots photograph. And then, your memories grow so bright, so warm, so familiar. Because there it was. Earth, that perfect blue marble floating in the darkness. The only world in all your travels where you knew, absolutely knew, that life was looking back at you. You remember that moment of approach, seeing Earth grow from a point of light to a disk to a sphere of impossible beauty. The blue of the oceans, so much water. More than any other rocky world in the solar system. The white swirls of clouds, weather systems the size of continents, hurricanes spinning like cosmic pinwheels. The brown and green of land, continents that drift across the surface over millions of years, mountains that rise and fall like slow-motion waves. But it's the atmosphere you remember most vividly, because that's where your dance began. That's where you transformed from a simple ray of light into something magical. The atmosphere of Earth isn't just a layer of gas. It's an ocean of air, 60 miles deep, getting thinner and thinner with altitude until it just fades into space. And you entered it like diving into the gentlest pool. First came the thermosphere, so thin it's barely there, where the International Space Station orbits, where the aurora dance. Those aurora, the northern and southern lights, they're caused by your cousins, charged particles from the sun hitting Earth's magnetic field and causing the air itself to glow. Green oxygen, red nitrogen, sometimes purple and blue, nature's own light show. Then the mesosphere, where meteors burn up, where the air is still too thin to breathe but thick enough to create friction, to turn space rocks into shooting stars. You pass through regions where noctilucent clouds form, the highest clouds on Earth, made of ice crystals that glow electric blue when lit by the sun from below the horizon. The stratosphere came next in your memories, home of the ozone layer, that precious shield that absorbs ultraviolet light. Some of your photon siblings ended their journey there, absorbed by ozone molecules, their energy going to protect life below. But you were visible light. You passed right through, though you remember the way the ozone made the air itself glow faintly blue. And then, the troposphere, the bottom layer, where weather happens, where clouds form, where life breathes. This is where your real dance began. This is where you stopped being just light and became color, became warmth, became the thing that makes rainbows possible. You see, when you entered Earth's thick lower atmosphere, you started bouncing, scattering, playing with molecules of nitrogen and oxygen. And here's the beautiful thing. Blue light scatters more than red light. It bounces around the sky like a pinball in a machine. That's why Earth's sky is blue. It's photons like you, dancing with the atmosphere, creating that beautiful dome of color that humans write poems about. You remember your first collision with a nitrogen molecule. It didn't hurt. Nothing hurts when you're light. It was more like a greeting, a gentle, hello, welcome to Earth. The molecule absorbed you for the tiniest fraction of a second, then released you in a slightly different direction. And then you hit another molecule, and another, and another. Each collision a new dance partner. Each scatter a new direction. Sometimes you'd hit water vapor, tiny droplets of water floating in the air. These collisions were different, gentler, like being wrapped in the softest blanket for just an instant. Water loves light, plays with it, bends it, splits it into rainbows when the angles are just right. You remember passing through a cloud, billions of water droplets all suspended in air, each one a tiny lens, a tiny mirror, bouncing you from droplet to droplet in a maze of reflection and refraction. This is why clouds look white. They're scattering all wavelengths of light equally, mixing them together into that pure, bright whiteness that makes clouds look like floating cotton. But the most beautiful memory, the one that still makes your wavelength shimmer when you think about it, was when you were part of a sunset. As the sun got lower in the sky, you and billions of other photons had to travel through more and more atmosphere to reach the ground. The blue light scattered away first, then the green, leaving only the reds and oranges and pinks to paint the sky in those impossible colors that make people stop their cars just to watch. You remember, finally, after all that dancing, all that scattering, reaching the surface. And what a surface it was. Oceans that reflected you back to space. Forests that absorbed you and turned you into food for trees. Deserts that bounced you back into the scorching air. Ice caps that reflected you so purely it was like looking in a mirror. And somewhere, on some ordinary day that felt special to no one but you touched a human face. Maybe it was a child playing in a garden. Maybe it was someone walking to work. Maybe it was a couple watching the sunrise. But for that briefest moment, after traveling for 100,000 years to escape the sun, after 8 minutes racing through space, after dancing through the atmosphere, you finally delivered your message. Your gift of warmth and light and energy that started as hydrogen fusion in the core of a star. Now your memories shift, pulling you back before Earth, back to that incredible 8-minute journey through the vacuum of space, from the sun to Earth. That sprint across 93 million miles that felt both instant and eternal. You remember it so clearly now. That feeling of absolute freedom after spending 100,000 years trapped inside the sun. Suddenly released. Suddenly flying at your true speed with nothing to slow you down. You remember the moment of escape, breaking free from the sun's surface, from that churning, boiling layer called the photosphere. The temperature there was about 10,000 degrees Fahrenheit, cool, almost cold compared to where you'd been. And suddenly, there was nothing in your way. No atoms to bounce off, no electrons to dance with, just pure, empty space stretching out before you like an infinite highway. The feeling was indescribable. Like a bird that's been caged for centuries, suddenly finding the door open. Like water that's been frozen for eons, suddenly melting and flowing. You were finally moving at the speed you were born to move. The only speed you can move when nothing's in your way. 186,000 miles per second. The cosmic speed limit that nothing can break. 8 minutes. That's all it took. 8 minutes to cross the entire distance from sun to Earth. Light from the sun takes 8 minutes and 20 seconds to reach Earth. And you were that light. You are that light. Every sunrise that humans have ever seen arrived 8 minutes after leaving the sun. Every sunset, every noonday, every photograph ever taken in natural light. All of it 8 minutes old by the time it arrives. During those 8 minutes, you pass through the solar wind, that stream of charged particles constantly flowing out from the sun. But they were so sparse, so spread out. You barely noticed them, like flying through the gentlest mist where the droplets are miles apart. The solar wind creates its own kind of weather in space. Solar storms that can make the aurora dance on Earth. But to you it was just a whisper, a breath, barely there. You remember passing Venus during one of those 8-minute journeys, that cloud-wrapped world that's Earth's twin in size but so different in every other way. Its atmosphere is so thick that the pressure at the surface would crush a submarine. so hot that lead would melt. The clouds are made of sulfuric acid, and the whole planet is surrounded by an electric glow, a halo of light created by the solar wind interacting with its atmosphere. Sometimes Mercury was in your path, that little scorched world closest to the sun. No atmosphere to speak of, just bare rock baking in sunlight that's 7 times more intense than on Earth. Its day side reaches 800 degrees Fahrenheit, while its night side drops to minus 290. A world of extremes. But you only saw the day side, the side that faces the sun, cratered and scarred like Earth's moon, but darker, more ancient. The space between the sun and Earth isn't truly empty. There's the solar wind, yes, but also dust. Tiny particles left over from comets, microscopic bits of asteroids, the debris of 4.5 billion years of solar system history. Sometimes you'd hit one of these dust grains, absorbed for an instant, then re-emitted. Your journey interrupted for less than a billionth of a second, but interrupted nonetheless. You remember the feeling of racing past Earth's moon during some of those journeys, that familiar companion that humans have been staring at since they first looked up. It takes light about 1.25 seconds to travel from Earth to the moon, so you'd pass it when you were almost done with your 8-minute sprint. The moon has no atmosphere, so photons that hit it either bounce off the rocky surface or get absorbed. No dancing, no scattering, just a simple reflection that creates that gentle moonlight that humans find so romantic. But now your memories are pulling you back further, to the moment of liberation itself. That instant when you finally escaped the sun's surface. You'd been struggling to get there for so long, 100,000 years, and then suddenly, freedom. The photosphere, the visible surface of the sun. It's not really a surface at all, just the layer where the sun becomes transparent enough for light to escape. Above it, the temperature actually increases. The chromosphere, the corona, layers of incredibly hot but incredibly thin gas that glow with their own strange light. You remember emerging through the photosphere like breaking through the surface of an ocean you'd been drowning in for millennia. Except you weren't drowning. You were dancing. Slowly dancing your way up from the core. The photosphere is only about 300 miles thick. Nothing compared to the 430,000 miles you'd traveled to get there from the center. But those last 300 miles felt different, special, because you could sense freedom approaching. The surface of the sun isn't smooth. It's covered in granules, convection cells about the size of Texas, where hot gas rises from below, cools, and sinks back down, like a pot of boiling water but on a scale that makes Earth look like a grain of sand. Each granule lasts only about 20 minutes, but new ones are constantly forming, constantly churning, making the sun's surface shimmer and dance. You emerged through one of these granules, riding the convection current up, up, up. The temperature dropping from millions of degrees to mere thousands. The density dropping too, from the thick plasma below to the thin gas above. And then, that magical moment, when the gas became transparent enough that you could finally escape, when nothing could hold you back anymore. You burst free along with trillions of other photons. a constant flood of light streaming out from the sun in all directions, some heading for Earth, others for Mars, for Jupiter, for the vast emptiness between the stars. Each photon on its own journey, but all part of the same endless river of light that's been flowing from the sun for 4.5 billion years. Above the photosphere, you pass through the chromosphere, that thin layer of pink gas that's visible during solar eclipses. It's hotter than the photosphere below it, which seems wrong, like water flowing uphill. But the sun doesn't follow intuition, it follows physics, and the physics says the chromosphere should be hot. So it is. Then came the corona, that ethereal crown of light that extends millions of miles from the sun. So hot that atoms are torn apart into ions and electrons. So thin that it's essentially a vacuum by Earth standards. The corona is where the solar wind begins, where the sun's atmosphere escapes into space, where magnetic field lines stretch and snap and reconnect in ways that create solar flares. You remember seeing a solar flare once, a magnetic explosion that released more energy in minutes than all of humanity has ever produced. The magnetic field lines got twisted, tangled, and then suddenly snapped back like a cosmic rubber band, sending clouds of plasma racing through space. Some of your photon cousins were created in that flare. High-energy X-rays and gamma rays that raced ahead of you toward Earth. But you were ordinary visible light, the kind that makes sunflowers turn, that makes plants grow, that lets humans see colors. And your journey from the sun's surface was beginning. That 8-minute sprint that you'd make countless times. Each time exactly the same, and yet somehow different. Because Earth was always in a slightly different position. Always showing a different face, different weather, different seasons. The freedom of those 8 minutes, after the imprisonment of 100,000 years, it was like the universe's greatest gift. And yet, now that you remember it all, the time inside the sun wasn't really imprisonment, was it? It was just a different kind of journey, a slower dance, a meditation that prepared you for this moment of release, and before that freedom, before those 8 minutes of pure flight. You remember the moment just before escape, when you were still inside the sun, but so close to the surface, so close to freedom. You were in the convection zone, that churning, boiling layer that makes up the outer third of the sun's interior, where the energy transport changes from radiation to convection, where hot gas rises and cool gas falls in endless loops. The convection zone. It's like the sun's own weather system, but instead of water and air, it's plasma. Ionized gas so hot that electrons are stripped from their atoms. The convection cells here are enormous, some as big as planets, rising from the bottom of the convection zone at about 500,000 miles from the sun's center, carrying heat up to the surface like cosmic elevators. You remember riding these convection currents, not by choice. Light doesn't choose, but carried along like a leaf on a stream. Sometimes you'd get caught in an upwelling, racing toward the surface with the hot plasma, making progress. Real progress after spending so long barely moving in the layers below. Other times you'd get pulled into a downdraft, sinking back toward the interior, losing altitude you'd worked thousands of years to gain. The convection zone is where the sun's magnetic field gets generated, where the differential rotation, the sun's equator spinning faster than its poles, twists and tangles magnetic field lines like cosmic spaghetti. These magnetic tangles are what create sunspots, those dark patches on the sun's surface that are actually as bright as the full moon, but look dark compared to the even brighter photosphere around them. You passed through regions where the magnetic field was so strong, it actually slowed down the convection, creating cooler areas that would eventually become sunspots when they reached the surface. You remember the feeling of those magnetic fields, not pushing or pulling exactly, but more like channels, guides, gently suggesting which way the plasma should flow. The temperature in the convection zone drops as you go outward, from about 4 million degrees at the bottom to those 10,000 degrees at the visible surface. Still hot enough to instantly vaporize any material from Earth, but positively freezing compared to where you'd been. You could feel the change, not as cold because light doesn't feel temperature, but as a change in the dance. The atoms moved more slowly here. The collisions were gentler, less energetic. Time moved differently in the convection zone. Not the endless meditation of the radiation zone below, but not the instant freedom of space either. It took you only about a week to rise from the bottom of the convection zone to the surface, when you caught a good updraft. A week, after spending tens of thousands of years in the radiation zone. Suddenly a week felt like nothing, like a heartbeat, like a single breath. But that week was full of motion, constant motion. The plasma in the convection zone moves at speeds of several miles per hour, which sounds slow until you remember that this is plasma with the density of gold moving through a space larger than 100 Earths. The kinetic energy involved is beyond human comprehension. Each convection cell carries more energy than all the bombs ever made. You remember the sound, except there was no sound. Not sound as humans know it, but there were pressure waves, vibrations in the plasma that astronomers can actually detect from Earth. The sun rings like a bell, with millions of different acoustic modes all vibrating at once, creating a symphony that's been playing for billions of years. You were part of that symphony, carried along by those pressure waves, rising and falling with the acoustic oscillations. The convection zone is where the sun does its mixing, where materials from different layers get stirred together like a cosmic soup. Helium produced in the core gets carried outward. Heavier elements get distributed. It's the sun's way of staying young, or at least middle-aged, preventing the helium ash from building up too much in the core, keeping the nuclear fires burning steadily. Sometimes you'd encounter magnetic flux tubes, rope-like structures of concentrated magnetic field that rise through the convection zone like submarine surfacing. These would eventually emerge as active regions on the surface, areas where solar flares and coronal mass ejections originate. You could feel their power, the way they organized the plasma around them, created order in the chaos. And through it all, through all that churning and mixing and rising and falling, you were getting closer to escape. You could sense it somehow, the decreasing density, the dropping temperature, the way other photons around you were starting to stream more freely, bouncing less, traveling farther between collisions. But now your memory pulls you back even further, to before the convection zone, to that vast region that makes up most of the sun's volume, the radiation zone. Oh, the radiation zone. This is where you spent most of your 100,000 years. This is where time really slowed down, where your journey became a true meditation. The radiation zone extends from about 250,000 miles from the sun's center to that 500,000-mile mark where the convection zone begins. It's called the radiation zone because this is where energy moves primarily by radiation, by photons like you, bouncing from atom to atom, absorbed and re-emitted, millions upon millions of times. The density here is incredible. Near the bottom of the radiation zone, the plasma is denser than water, denser than rock, almost as dense as iron, and it's hot, so impossibly hot. 15 million degrees at the bottom, cooling to only 4 million at the top. At these temperatures, atoms don't really exist as humans think of them. Everything is plasma, a soup of nuclei and electrons all swimming around each other. This is where your journey became what scientists call a random walk. Though there's nothing random about it when you're experiencing it. Every collision is perfect, predetermined by the laws of physics. You bounce off an electron, get absorbed by an ion, get re-emitted in a completely different direction, and repeat, and repeat, and repeat. The mean free path. That's what scientists call the average distance you could travel between collisions. In the radiation zone, it's about 1 centimeter, less than half an inch. That's it. That's all the freedom you had. Half an inch before another collision, another absorption, another re-emission, and you had to travel 250,000 miles this way, half an inch at a time. Do the math and it becomes clear why it takes so long. If you could travel in a straight line, you'd cross the radiation zone in just over a second. But you can't travel straight. You zigzag, you backtrack, you spiral, you wander. Sometimes you make progress outward. Sometimes you go sideways. Sometimes you actually go backward, deeper into the sun. It's like trying to cross a crowded room where everyone is constantly moving. And every time you bump into someone, they spin you around and point you in a random direction. Now imagine that room is 250,000 miles across, and there are more people than there are grains of sand on all the beaches on Earth. That's the radiation zone. But here's the beautiful thing, the thing that makes it meditation rather than chaos. Each collision is gentle. Each absorption is like being embraced, held for just a moment by an atom that needs your energy. And each re-emission is like being released with a blessing, sent on your way with good wishes. The atoms you met in the radiation zone, they weren't strangers, not after the first million collisions. They were all hydrogen and helium nuclei, the same elements over and over, and you got to know them intimately. A hydrogen nucleus, just a single proton, so simple, so pure, it would catch you, hold you for about 1/1000th of a second, then let you go. And in that 1/1000th of a second, you were part of it. You were united with it, sharing your energy, sharing your existence. Helium nuclei were different, heavier, with 2 protons and usually 2 neutrons. They held you a little differently, absorbed you with a slightly different resonance. Like the difference between being hugged by a child and being hugged by an adult. Both warm, both welcoming. Just different. And the electrons. Oh, the electrons. They didn't absorb you. They scattered you, deflected you like tiny mirrors. They're so much lighter than the nuclei, zooming around at incredible speeds. And when you hit one, it was like a cosmic game of billiards, a perfect elastic collision that sent you careening off in a new direction, while barely affecting the electron at all. 50,000 years into your journey through the radiation zone, you were still closer to the core than to the convection zone. That's how slow progress was. 50,000 years of bouncing, of zigging and zagging, and you'd only made it maybe a third of the way out. But you weren't frustrated. Light can't be frustrated. You just were, existing in an eternal now. Each collision its own complete universe. The temperature was gradually dropping as you worked your way outward, from 15 million degrees to 12 million, to 10 million, to 8. The collisions became slightly less violent, slightly less energetic. The atoms moved a bit more slowly, held you a bit longer. The plasma was becoming less dense too, giving you slightly more room between collisions. 1.5 centimeters instead of just 1. You remember a particular moment, though moment isn't really the right word when you're talking about something that lasted 1,000 years. You got caught in what astronomers would call an eddy, a slow, swirling motion in the plasma. You went around and around, not making any progress outward, just circling in place like a cosmic whirlpool, bouncing from atom to atom in a rough spiral that kept bringing you back to where you started. For 1,000 years, you danced in that one small region of the sun, an area no bigger than Earth, just circling, meeting the same atoms over and over, getting to know them like old friends. There was one helium nucleus in particular. You must have encountered it millions of times during that millennium, each time recognizing its particular energy signature, its specific way of absorbing and re-emitting light. That's when you really understood what patience means, or what it would mean if you could understand. 1,000 years in one spot. And then finally, a collision at just the right angle, a scattering event that sent you shooting outward, free from the eddy, back on your journey toward the surface. 75,000 years in, 3/4 of your journey through the radiation zone complete, and the environment was changing. The temperature was down to about 6 million degrees, still hot enough to instantly destroy any normal matter, but cool compared to where you'd been. The plasma density was dropping too. You could travel almost 2 centimeters between collisions now, double what you could at the start. You were entering a region where the sun's composition starts to change slightly. Near the core, the helium abundance is higher. All that helium ash from billions of years of fusion. But out here, it's mostly hydrogen. Primordial hydrogen that's been here since the sun formed, waiting its turn to be cycled down into the core and fused into helium. The collisions here had a different quality, softer somehow. The lower temperature meant the atoms weren't moving as fast. When they absorbed you, they held you just a tiny bit longer. When they re-emitted you, it was with less violence, more like being passed gently from hand to hand, rather than being thrown. 90,000 years into your journey, so close to the convection zone you could almost taste it, if light could taste. The radiation zone was thinning out, becoming less efficient at transporting energy. That's why the convection zone exists. At a certain point, about 70% of the way out from the center, the temperature gradient becomes so steep that radiation can't carry all the heat anymore. Convection takes over, bulk motion of matter rather than the patient photon by photon transfer you'd been doing. You could feel it approaching, that transition. The plasma around you was starting to become unstable, wanting to rise, wanting to convect, but still dense enough that you were bouncing your way through it, collision by collision. Your mean free path was up to almost 5 centimeters now. 5 whole centimeters of freedom between each atomic encounter. And then you remember the strangest part of the whole journey. Those last few thousand years in the radiation zone, when time seemed to slow even more, if that was possible. Each collision became more significant, more memorable, because you knew, somehow you knew, that your long meditation was coming to an end. You started noticing things you'd missed before, or maybe they weren't there before. Tiny variations in the plasma density, wisps and streams where the material was just slightly hotter or cooler. The beginning hints of the convection that would soon dominate. Like watching ice just beginning to melt, still solid, but somehow different, ready to change phase. 100,000 years, give or take a few millennia. That's how long it took you to random walk your way through the radiation zone. 100,000 years of bouncing from atom to atom. Each collision a gentle greeting, a brief embrace, a soft farewell. No violence, no chaos. Just an endless, patient, peaceful dance. And during all that time, during every one of those countless trillions of collisions, you were never damaged, never diminished. Your energy decreased gradually as you moved outward and the temperature dropped. Your wavelength got a bit longer, your frequency a bit lower. But you were still you, still the same packet of energy that was born in the core, still carrying that same fundamental message from the heart of a star. But now your memory pulls you back even further, deeper into the sun, deeper into time, back to those first few thousand years after your birth, when you were still near the core, when everything was new, when your journey of 100,000 years was just beginning. The deep radiation zone, the region just outside the core. This is where your meditation truly began. The temperature here was almost as hot as the core itself. 14 million degrees, 15 million. The density was incredible, more than 10 times denser than gold. And yet it was all gas, all plasma, compressed to impossible densities by the weight of 400,000 miles of star pressing down. Your first 1,000 collisions happened in your first second of existence, before you'd traveled even an inch from where you were born. The atoms were so packed together, the electrons so numerous, that you couldn't go anywhere without hitting something. It was like trying to fly through honey, cosmic honey made of nuclear matter. But each collision was perfect. Each one followed the exact laws of quantum mechanics. Each absorption lasted exactly as long as the uncertainty principle allowed. Each re-emission sent you off in a direction determined by probability waves that humans wouldn't discover for billions of years. You remember meeting your first electron, That tiny particle with its negative charge and its impossible speed. It scattered you without absorbing you, like a mirror made of pure charge, sending you off at an angle that depended on exactly how close you came to it. A perfect dance of electromagnetic forces. Your first hydrogen nucleus, your first proton. It welcomed you like you were meant to be there. Absorbed your energy for that brief moment, incorporated you into its being, then released you when quantum mechanics said it was time. No longer the same photon exactly, but carrying the same energy, the same information, the same message from the fusion reaction that created you. Those first few years in the deep, radiation zone taught you what you were, what it meant to be light. You learned that you could be absorbed but not destroyed, scattered but not broken, that you were both particle and wave, both local and universal, both temporary and eternal. The first 100 years near the core, they passed like a dream within a dream. You made it maybe a few hundred meters from your birthplace, that's all. A few hundred meters in 100 years. But distance didn't matter down there. Nothing mattered except the dance. The eternal dance of energy being passed from atom to atom like a secret whispered through an infinite crowd. The core extends out to about 150,000 miles from the sun's center. That's where fusion happens, where hydrogen becomes helium, where mass becomes energy, where you and billions of other photons are born every second. And just outside that core, in those first few thousand miles of the radiation zone, that's where traffic is the worst. Where all the new photons like you are trying to escape while the plasma density is at its highest. You remember the feeling of being surrounded by your siblings, other photons born in the same fusion reactions, some a microsecond before you, some a microsecond after, all of you trying to escape, all bouncing off the same atoms, all playing the same slow-motion game of pinball. Sometimes you'd encounter the same photon multiple times, scattered off the same electron, absorbed by the same helium nucleus, like dance partners who keep finding each other in a crowded ballroom. 500 years in, you'd made it maybe half a mile. The temperature was still over 14 million degrees. The density still more than 10 times that of gold. Every direction looked the same, felt the same. There was no up or down, no in or out. Just an endless sea of plasma with you bouncing through it one collision at a time. 1,000 years passed, 2,000, 3,000. You were maybe a mile from where you started, maybe 2. Progress was so slow it could barely be called progress. More like a gradual drift, a statistical tendency to move outward that only became apparent over centuries. But during those first few thousand years, something beautiful happened. You learned the rhythm of the sun, not a rhythm in time, but a rhythm in space, in probability, in the way energy flows through plasma. You learned that every collision had a slightly better chance of sending you outward than inward. Just slightly, maybe 51% outward versus 49% inward. But over millions and billions of collisions, that tiny difference added up. You remember encounters with heavier nuclei during those early years. Not just hydrogen and helium, but traces of carbon, nitrogen, oxygen, elements left over from the star that died to birth our sun. because that's what happened. Billions of years before our sun formed, another star lived and died, went supernova, scattered its enriched guts across space, and those heavier elements became part of the cloud that collapsed to form our solar system. These heavier nuclei were rare, maybe one in every million collisions, but they were memorable. They absorbed you differently, held you with more complex electron shells, re-emitted you with subtle differences in timing. Like meeting someone from a faraway land in a crowd of locals. Exotic, different, special, 4,000 years, 5,000, 6,000, still in that deep, dense region just outside the core. The sun above you, if above had any meaning, weighed 600 billion tons. That weight, that pressure, it's what keeps the core hot enough for fusion. It's what makes your prison, your meditation chamber, possible. You developed a kind of rhythm, if something without consciousness can have rhythm. Bounce, absorb, emit. Bounce, bounce, absorb, emit. Scatter, bounce, absorb. Each collision blending into the next. Each atom becoming familiar. The whole experience becoming one long, continuous moment that lasted millennia. Sometimes you'd get lucky. A series of collisions that all happened to send you outward, and you'd make real progress. Maybe a whole meter in just a few days. But then you'd hit an unlucky streak, scattered backward over and over, losing weeks of progress in minutes. It didn't matter, couldn't matter. You just kept going, kept bouncing, kept existing. And now your memory reaches back to the very beginning, to before the bouncing, before the collisions, to that perfect moment of your birth. You remember it with absolute clarity, even though remembering isn't quite the right word. The memory is encoded in your very being, in your wavelength, in your frequency, in the fundamental nature of what you are. You were born in violence, though it didn't feel violent. It felt like becoming, like not existing and then suddenly existing, like the universe saying, "Let there be light," and you answering, "Here I am." It happened in the core, in that central furnace where the temperature is 15 million degrees, where the pressure is 250 billion times Earth's atmospheric pressure, where conditions are so extreme that the normal rules of matter break down and magic happens. Nuclear magic, fusion, 4 hydrogen nuclei, 4 simple protons, had been dancing around each other for millions of years, sometimes coming close, sometimes moving apart. The temperature giving them enormous speed, the density keeping them close together, and the quantum mechanical probability that eventually, they would overcome their electrical repulsion and get close enough for the strong nuclear force to grab them. The process wasn't simple. It never is in stars. First, 2 protons had to collide with enough energy to overcome their mutual repulsion. They're both positively charged. They don't want to get close. But at 15 million degrees, they're moving so fast that sometimes, rarely, they collide head-on with enough force to get within range of the strong force. And when that happens, something magical occurs. One of the protons transforms. A quantum transformation where a proton becomes a neutron by emitting a positron and a neutrino. The positron is antimatter, the antimatter version of an electron. And the neutrino, That ghostly particle that barely interacts with anything. It flies straight out of the sun without a single collision. The proton and the new neutron stick together, forming deuterium, heavy hydrogen, and in that moment of sticking, binding energy is released. The mass of the deuterium is slightly less than the mass of the original proton plus neutron, and that missing mass, that tiny bit of matter that disappeared, it became energy. It became you. Well, not quite yet. You weren't born in that first step. You were born in what came next. The deuterium nucleus quickly, within seconds usually, collided with another proton, fusing to form helium-3 and releasing a gamma ray, a high-energy photon. That was you. That was your birth. You came into existence carrying 5.49 MeV of energy. That's how physicists measure it. But what it really means is you were born screaming with the energy of matter converting directly into light. Einstein's E-mc2 in its purest form, a tiny bit of mass, a fraction of a proton's worth, transformed into pure electromagnetic energy. You were a gamma ray in that first moment, the highest energy form of light, invisible to human eyes, but carrying enough energy to damage DNA if you ever reached Earth unchanged. But you wouldn't reach Earth unchanged. Your 100,000-year journey would transform you, cool you, stretch your wavelength until you became the gentle, visible light that makes life possible. The fusion reaction that created you, it's happening constantly in the sun's core. 400 million tons of matter converting to energy every single second. That's how much the sun loses. 400 million tons per second, just radiating away as light. And yet the sun is so massive, it can keep this up for billions of years. You were one photon among septillions created that second, but you were unique. Your exact energy, your exact trajectory, your exact moment of creation, they were yours alone. No other photon would ever be exactly like you. No other packet of light would carry exactly your quantum signature. In that first instant after your birth, you traveled maybe a millimeter before your first collision, a millimeter of perfect freedom at the speed of light, and then impact, your first absorption. A helium nucleus grabbed you, held you for a billionth of a second, then released you with slightly less energy. You were no longer a gamma ray. You'd become an X-ray, still invisible, still deadly to unprotected life, but already beginning your long transformation. That first collision set the pattern for all that would follow. Bounce, absorb, re-emit, each time losing a tiny bit of energy to the surrounding plasma. Each time your wavelength getting a tiny bit longer, your frequency a tiny bit lower. Like a ball bouncing down an infinite staircase, where each step takes centuries to descend. Within your first second of existence, you'd been absorbed and re-emitted 1,000 times. You'd gone from gamma ray to X-ray to far ultraviolet, your energy spreading out, sharing itself with the plasma around you, heating it, maintaining the pressure that keeps the sun stable. That's your real job, you see. Not just to escape and bring light to the universe, but to transport energy from the core where it's created to the surface where it can radiate away. Without you and your countless siblings, the sun would either collapse or explode. It's the pressure of your radiation, the constant outward push of light, that balances gravity's inward pull. Your first hour was a blur of collisions, millions of them. You'd made it maybe a few centimeters from your birthplace. Your wavelength had stretched from gamma ray through X-ray to extreme ultraviolet. You were already unrecognizable from the high-energy photon born in fusion, but you were still you, still carrying that same fundamental packet of energy, just spread out over a longer wavelength. Your first day, your first week, your first month. Time meant nothing in that dense plasma. Every moment was the same, collision after collision, bounce after bounce. The slow, random walk had begun, the meditation that would last 100,000 years. And through it all, through every collision, every absorption, every re-emission, you were perfect. You were exactly what the universe needed you to be. A messenger, a carrier of energy, a tiny thread in the vast web of light that holds stars together and makes life possible. You couldn't know then what you know now, that your journey would take you from the heart of a star to the edge of the observable universe, that you'd warm faces on a small blue planet, that you'd become part of the sunset that makes lovers stop and stare, that you'd travel billions of years into the future, becoming part of the cosmic background, the faint glow that fills all of space. But even if you could have known, it wouldn't have changed anything. You would still have bounced from atom to atom, still have pursued your random walk, still have meditated your way through 100,000 years of patient progress. Because that's what light does. It travels, it endures, it connects everything to everything else. And now, as your memory completes its circuit, as you remember your birth and your journey and your escape and your arrival at Earth and your continued journey to the edge of everything, you understand something profound. You're not just a photon. You're not just a packet of light. You're a story. A story that began with hydrogen fusing in the heart of a star and will continue until the universe itself grows cold and dark. But that's so far in the future, it might as well be never. For now. For the eternal now that light experiences. You simply are. You exist. You travel. You remember. And in your remembering, the universe remembers itself. And so, here we are, at the end of our backward journey through time. Or perhaps it's the beginning. When you're light, every ending is also a beginning. Every destination is also a departure point. The circle is complete. From your birth in nuclear fire to your journey across the universe. From the edge of everything back to the moment of creation. And now, gently, peacefully, we return to the present moment, to here, to now. You've traveled with a photon tonight, been a photon, felt what it might feel like to bounce patiently from atom to atom for 100,000 years. You've experienced time the way light experiences it, as one eternal moment that contains all moments. You've seen the universe from the inside out, from the heart of a star to the edge of existence. And maybe, just maybe, you'll never look at sunlight the same way again. Tomorrow, when the sun rises, or whenever you next feel warmth on your skin, remember this journey. Remember that the light touching you is ancient, that it's been meditating its way through the sun since before humans existed, since before the pyramids were built, since before the ice ages. It began its journey when Earth was a different world, and it's finally finally reached you. Just to say hello, just to warm your face, just to remind you that you're connected to the cosmos in ways more intimate than you ever imagined. And if you're still awake, still floating through these cosmic memories with me, that's perfectly okay. There's no need to force sleep. Sometimes our minds want to wander among the stars a little longer, want to drift through these infinite spaces where time doesn't matter and patience is infinite. If you'd like to continue this journey, if your mind is asking for more, there's another story waiting for you. Just let it play. No need to move. No need to even open your eyes. The next adventure will begin automatically, carrying you deeper into the cosmic ocean. Maybe we'll explore the birth of the moon, or the dreams of Jupiter, or the ancient songs of Saturn's rings. Whatever comes next, it'll be gentle, peaceful, designed to carry you further into rest. Or maybe you're already drifting, already feeling that sweet pull of sleep. That's beautiful too. There's no wrong way to end this journey. Whether you follow into the next story or drift off into your own dreams, you're exactly where you need to be. I want to thank you for joining me tonight, for trusting me with your time, your attention, your journey towards sleep. It means more than you know that you've chosen to spend these moments exploring the universe together. Every night when I tell these stories, I imagine you there, getting comfortable, letting the day fall away, finding peace in the vastness of space and time. You know, there's something magical about what we've shared tonight. We've taken something that could be overwhelming, the idea that sunlight takes 100,000 years to escape the sun, and we've turned it into something peaceful, something meditative, something that reminds us that the universe operates on timescales that make our daily worries seem so small, so temporary, so manageable. And now, as you lay there, as your breathing has already become deeper, slower, more rhythmic, I want you to know that you can return to this feeling anytime, this sense of cosmic patience, of universal peace, of being part of something so much larger than yourself. It's always there, in every ray of sunlight, in every star you see, in every photon that's been traveling since the beginning of time just to reach your eyes. Your body is so heavy now, so comfortable. Every muscle has released its hold on the day. Your mind is floating, drifting, like light itself, unbounded by the weight of matter, free to travel wherever it needs to go. And whether that's into sleep, into dreams, or into another story, you're safe, you're peaceful, you're exactly where you belong. The photons are still traveling right now as you drift off. New ones are being born in the sun's core, beginning their 100,000-year journey. Others are just breaking free from the surface, starting their 8-minute sprint to Earth. And somewhere, billions of light years away, photons that left our sun when you were young are still traveling through the cosmic dark, carrying their ancient memories across the universe. You're part of that story now. You understand the secret patience of light, the meditation of particles bouncing gently from atom to atom, the peace that comes from knowing that some journeys can't be rushed. Some things just take the time they take. And that's not just okay, it's beautiful. So sleep now, if sleep is calling you. Dream of patient light and gentle collisions, of cosmic time and stellar meditation. Dream of being both particle and wave, both here and everywhere, both now and always. Let your consciousness scatter like starlight, spread out like the dawn, drift like photons through the dark. And remember, every sunrise is a gift that's been 100,000 years in the making. Every sunset is a masterpiece, painted with ancient light. Every moment of warmth on your skin is a message from the heart of a star, delivered across impossible distances, just for you, just for this moment, just for now. Good night, my friend. Sleep well, dream deep. May your rest be as patient as light in the sun, as peaceful as the space between stars, as perfect as the dance of atoms in the dark. Sweet dreams, sweet dreams, sweet dreams.